So good morning everyone. My name is Amit Kumar Singh and welcome to the second class on risk analysis on capital budgeting. Yesterday I have started discussing the concept of risk, what risk is all about. We discussed the relevance of risk on the historical data point of view, and then we discussed the relevance of risk in the context of the present economic scenario where everything is very random. So because everything is very random and whatever has happened in the past doesn't mean that it's gonna have a significant influence on the present and future. So probably we discuss in the term of what you can say as developing scenarios, and while working on scenarios we try to determine the best case scenario which can give the required output what we are expecting about. So that's why the modeling exercise which the computers can generate for us based upon the different scenarios while working on the probability, ultimately it become very relevant for all of us. So whenever we are talking about investment, what matters for us is how we can analyze an investment. And when I was talking about the calculation of risk or the estimation of risk, at that time I have discussed starting about how you we how we can use this discussion of risk probably. Yeah, so we have discussed how we can use the relevance of the risk probably in the capital budgeting decision. So when we talk about capital budgeting decision, it requires lot of understanding in the context that whenever we talk about capital budgeting is all about capital budgeting is all about preparing for the future. So when we are trying to prepare ourselves for the future, what ultimately matters here is as a investment planner for a company, how you can analyze the risk, what your budget or what is your investment can go through in the future. So you need to figure out the decision making requirement under certainty. You need to figure out your decision making responsibility involving risk. You need to figure out your decision making ability under the different conditions of uncertainty. So while discussing about all these contests about capital budgeting decision, we have discussed about whenever we prepare ourselves for the capital budgeting homework as a company or as an investment planner for the company, what important is to analyze the project, and the most common tool for the analysis for the project is NPV. So when we talk about NPV stands for net present value. So when we say net present value, what net present value is all about? It is basically when we say net present value is basically the cash inflows what we are expecting to receive from the project. So the present value of your future cash inflow, what you're going to expect to receive from the project, and this we subtract from the initial investment. So this is your NPV. So what ultimately matters that although this looks very simple, that this NPV calculation, and already we have discussed about NPV calculation in the past exercises, what ultimately matters is that how we can analyze the situation in a complex environment. Because when we are talking about probability, then we may analyze the situation by using a decision tree. So we may analyze the situation by using decision tree. So if you work on decision tree analysis, if you work on a decision tree, if you work on the decision tree analysis, if you work on decision tree analysis, if you work on decision tree analysis, then ultimately we discuss the different scenarios, what our project can go through, and then probably we understand that will this project will be feasible or not. So based on that condition, let's do one problem. So based on that condition, let's do one problem which came for you in exam in past. So we'll do one case study for you people which came in the past. Mm. So you can see this question, everyone I believe can see this question very well. So there's a company is there. A company is trying to decide whether to invest in a new project. So let's understand this case study. This came for 15 marks for you. So a company is trying to decide whether to invest in a new project. So a company is thinking that should they invest or not on the new project. So two mutually exclusive projects are available. Two mutually exclusive projects are available for the company, each requiring an investment of 3 lakh rupees. So two projects are available with the company and both of them requires an investment of 3 lakh rupees. Project A is expected to generate cash inflow of 2 lakh rupees per year for the next 2 years. Okay, and so the when you talk about project A requires an investment of 3 lakh rupees and it will generate 2 lakh rupees for the next 2 years. Okay, so then if you see there's nothing else is given about project A. So let me talk about project A. So if you talk about project A, so here so project A 2 year is there 1 and 2 and the cash inflow, the project A will generate a cash inflow of 2 lakh rupees. Project A will generate a cash inflow of 2 lakh rupees. So the 2 year is the life of the project A and it will generate a cash inflow of 2 lakh rupees per year. So you can say that it will generate a total of 4 lakh rupees. You can say that it will generate a total of 4 lakh rupees and the initial investment is 3 lakh rupees. So probably you can say that yeah, then it makes sense because the initial investment is 3 lakh rupees and it is generating 4 lakh rupees. So you think that okay, 4 lakh is better. I'm receiving 4 lakh and I'm putting 3 lakh. So you can say that you can consider this project. You can think that okay, yeah, you can consider this project because you are not considering the time value of money. If you are not considering the time value of money, so you can say yeah, you can consider this project. But when you start understanding the concept of time value of money, when you understand that the 2 lakh rupees what you get at the end of first year is not equal to the 2 lakh rupees what you get at the end of second year, so then what you need to do, you need to determine the present value of these cash flows. So there would be some discounting factor given in the problem. So if I read this problem, so rest all the data is of project B only. So that here you can see the firm uses 14%. You can see a firm uses 14%. A firm uses 14%. You can see a firm uses 14% minimum required rate of return for deciding whether to invest in a project comparable in risk to the other in consideration. So here you can understand that your discounting rate is 14%. So now if I discount with 14%, now if I discount this with 14%, now if I discount this with 14%, if I discount this with 14%, so the present value of your cash flow, so the present value of your cash flow that will be 2 lakh, that would be 2 lakh divided by 1 plus 14% for year 1. So this would be 2 lakh, this would be 2 lakh divided by 1.14. You can use calculator to find this value. So 2 lakh divided by 1.14. This is after 1 year. So what is the present value of that? So you can find it out that. So you can find that. So 2 lakh, 1, 2, 3, 4, 5. 2 lakh divided by 1.14. That will be 175,438. That will be 175. That will be 175,438. 175,438. 0.5964. 0.5964. Now, this 2 lakh rupees, what you're getting after 2 years. So this 2 lakh rupees, what you're getting after 2 years, the present value of that is 2 lakh divided by 1 plus 14% to the power 2. This would be 2 lakh divided by 1.14 to the power 2. So this would be this whatever the value, whatever the value you got, whatever the value you got, divide this by 1.14. So you get 1,50,000. You will get 1,53,893.50.505. If you add them, if you add them together, 17,1,754,38,17,543,8.5964. So you will get the value called 3,29,000. You'll get 3,29,332, 3,29,332.102. This is the net cash inflow what you're getting. While if you see the initial investment, your initial investment was 3 lakh rupees. If you see your initial investment was 3 lakh rupees. So the NPV of the project would be 3,29,332.102. To subtract with 3 lakh, if you subtract with 3 lakh, you'll get 29,332. So this would be the NPV of project A. So this is the NPV of the project A. So now I got the NPV of project A. Then I'll find the NPV of project B, and I'll see whichever project is giving me better NPV. I'll accept that project. You need to understand that in this problem, the decision maker has two mutually exclusive projects, so he cannot take both of them together. Okay, so out of A or out of B, project A or project B, he has to choose one project. Either he has to choose project A or either he has to choose project B. He cannot take both of the project together. I hope you can understand this. So the NPV of this project is 29,332 rupees. Okay, so I guess you have understood this. So for project A, so I have done the NPV calculation for project A. So I have done the NPV calculation for project A. So this is the NPV calculation of project A of project A. So I have done NPV calculation for project A. I believe you have understood this. After this, I'll do for project B. Any doubt, Manju? Any doubt? Anyone? Ranjit, Sri Prasad, anyone? Monisha, anyone? Any doubt? Anything you want to ask? Mohan, any doubt? Bharat, any doubt? Huh? So So this we did for A, guys. So see the purpose why I did for A first, because A is very easy to do. Now for B we require a little bit of more understanding. So we'll take more time on B. So that's the reason I thought, okay, let's do the something which is easy. Now we'll talk about B. So now we'll talk about NPV calculation of B. Now we'll do NPV calculation of project B. Now we'll talk about NPV calculation of project B. So talking about project B, the things may become complex because it's a 15 marks question. It is not 5-10 marks question. So you need to understand now. Now talking project B. So now if you start from, let me just see. Now I'm starting from project B. Okay, this is the line. This is the line what I'm going through. I'm just showing you. So it is estimated that the cash flow associated with project B would be either 1,80,000 or 2,20,000, each with probability 0.5. Okay, now the things will become complex for project B. So 1,80,000 or 2,20,000. Project B, this is the initial investment. Initial investment is 3 lakh rupees. Initial investment is 3 lakh rupees. So it can be 1,80,000 rupees with probability 0.5, or it can be 1,80,000 rupees with probability 0.5. 1,80,000 rupees with point probability 0.5, or it can be 2,20,000 rupees with probability 0.5, or it can be 2,20,000, or it can be 2,20,000 rupees with 0.5. Now these all the questions of decision tree. So, or it can be 2,20,000 rupees with probability 0.5. Okay. Okay, or it can be 2,20,000 with probability 0.5 next year. Okay, so you have to understand, guys. You need to understand this. This what I'm talking about. This is for next year. This is for year one. This is for year one. You have to understand this is for year one. This is year zero. Okay, initial investment. Okay, so that point, be clear on that point. Okay, now going further, what is given? So if so, it can be 1,80,000 or 2,20,000 each with probability 0.5. If 1,80,000 receive in the first year, if 1,80,000, see this line, everyone. If why is not happening? So see this. If 1,80,000 rupees is received in the first year, if 1,80,000 received in the first year, the cash flow for second year is likely to be 1,50,000, a probability 0.3, 1,50,000 probability 0.3, 1 lakh can be 1,50,000, 1,50,000 probability is 0.3, 1,50,000, 1,50,000 probability is 0.3. Uh, so if 1,80,000 received in the first year, the cash flow for second year is likely to be 1,50,000 probability 0.3, 1,80,000 probability 0.4, 1,80,000, 1,80,000 probability 0.4, 1,80,000 probability 0.4, 1,80,000 probability 0.4, or 2 lakh probability 0.3, or 2 lakh probability, or 2 lakh probability, or 2 lakh or 2 lakh probability 0.3, or 2 lakh probability. So let me do can you 1,50,000.3, 1,50,000.3, 1,80,000.4, 1,80,000.4, or 2 lakh or 2 lakh 0.3, or 2 lakh 0.3, or 2 lakh 0.3. This can be the case. Okay, so you understand, no? This is for project for this is for if, so if this is 1,80,000, if this is 1,80,000 in first year, then this is gonna happen, then this all gonna happen. You understand this? Okay. Then this is all gonna happen. So if 1,80,000 in the first year, then all this gonna happen. Okay. Now then after this, so it can be 1,50,000.3, 1,80,000.4, or 2 lakh point 3, or 2 lakh point 3. Okay. Then in case the first year cash flow is 2 lakh 20. Okay. Now in case if the cash flow is 2 lakh 20, in case the cash flow is 2 lakh 20, the second year likely cash flow can be 1 lakh 80, 2 lakh 70, 1 lakh 80, or 2 lakh 70, 1 lakh 80, or 2 lakh 70. So now this, so in case 1 lakh 80, if this is the case, so it can be so in case if the first year cash flow is 2 lakh 20, the second year likely cash flow will be 1 lakh 80. It would be 1 lakh rupees, 1 lakh 80 rupees, 1 lakh 80, or it can be rupees 2 lakh 70, or it can be rupees 2 lakh 70, or it can be rupees 2 lakh 70, or each with probability 0.3. So each with probability 0.3, each with probability 0.3, each with probability 0.3, and 2 lakh 20 with probability 0.4, and 2 lakh 20, and 2 lakh 20, and 2 lakh 20 with probability 0.4. extend, yeah. So this is the case. So the second year likely. So if the cash flow is 2 lakh, then cash flow 1 lakh 80, 1 lakh 80, or 2 lakh 70, or 2 lakh 20 with point 0.4. Okay. Then okay. So you then the discounting rate is 14%. Okay. What you need to do, you need to calculate the risk adjusted expected NPV for project A and project B. Project A already I have determined the risk adjusted at the expected NPV. Okay, then let me do for B. Now let us do for B. So you need to understand there are two ways are there how you can solve this for B decision tree problem. I'll tell you both the way. Okay, so one by one we'll solve this. Now solve this. Now this is 1 lakh 80, 30% is 20. 18 3 is 54. So this would be 54,000. 27 3 is 81. This would be 81,000. And 2 lakh 20, 40% is 80, 22 fours are 88. So 88,000. Do the sum of this. So the likely cash flow here would be, if you do the sum of this, so this is 8 plus 4, 12, 13, 1 carry. 1 carry means 16, 17 plus 5, 17 plus 5, 22. 2 lakh, 2 lakh 23,000. So this would be 2 lakh 23,000. So this would be 2 lakh 23,000 for second year. This is for second year. This is for second year. You understand? This is so the expected uh, so the expected cash inflow in second year, expected cash inflow in second year. This is the expected cash flow in second year. If so, if if the cash inflow if the cash inflow was rupees 2,20,000 in first year. So this is the case. Is this clear? So this is the expected cash inflow in the second year if the cash inflow was 2,20,000 in the first year. So this is the expected cash inflow in the second year if the cash inflow was 2,20,000 in first year. So this is the likely cash inflow for you for the second year. Okay, but you need to understand this this is the cash inflow. You need to understand this 2,20,000, 2 lakh. You need to understand that you need to understand this is 2,23,000. This is for second year. This is for second year when your cash inflow was 2,20,000 in the first year. Okay, you are getting this. So now I'll try to bring 2,23,000 what I got here. I'll try to bring it here. I'll try to bring 2,23,000 here. But how can I bring it here? You need to understand that you cannot bring it here. You need to understand this is 2 lakh. You need to understand this is 2,20,000. You need to understand this is 2,20,000. This is after first year. This is after second year. So how will you bring it here? You'll bring it here by 2,23,000 by dividing with 1.14. That is your discounting rate. This is for year one. This was for year two. So how will you bring the data of year two back to the year one? So by discounting that value at 14%, because 14% is your discounting rate. So this is the cash inflow for year one. This is the cash inflow for year one with probability 0.5. So this is the cash inflow for year one with probability 0.5. So this is the way you need to do. Now you solve this value. So this is the cash inflow for year one on second case scenario. So this is the second case scenario. So the cash inflow for second case scenario. For second case. Okay, that was the earlier one is first case. This is second case. So the 2,23,000, that was the cash inflow after second year. 2,20,000 is the cash inflow after first year. So how will you bring the 2,23,000 which was there for after second year to the first year? By discounting that with 14%, because 14% is your discounting rate of return. Okay, so now let me solve this. Let me find this value. So this is 223, then 000 divide by 1.14. So you got 195,614.0350. This plus 2,20,000. 1 2, then how many zero? Four zeros. Vandu Erudu, Vandu Erudu, Muru Nalku. So you got 4,15,000. So you got this as 4,15,000, 4,15,614, 4,15,614.035. This is the cash inflow for the second case. So this is the cash inflow 4,15,614.035. So this is the cash inflow for the second case. Okay, so this is the cash inflow for second case for the first year. For the first year, we are not at reached the initial year. So this is the cash inflow for second case for the first year. Okay, anyone have doubt till now? Anyone, any doubt? Anything you want to ask? Then I'll go to the first case. Anyone want? Anyone want to ask anything? Anything you want to ask? Please message here. Anyone? Rosa, any doubt? Suhas, any doubt? Mohan, Manju, Malika Arjun, Jayant, Darshan, any doubt? Bharat, two Bharat are there. I know only one Bharat. Okay, great. Roja is clear. Roja have no doubt. Okay, clear. So we'll go ahead to the this. So you can see this. Now we'll talk about the first. We did the second case. We did the second case. We did the second case, and we got the value after first year. The same thing I'll do for the first case. So here if you see, so this data is for year two. You understand this data is for year two. So this value would be 45,000. This would be 45,000. This would be 72,000. This would be 60,000. 2,60,000. So cash inflow what you're getting is 7. Then 1,77,000. So the year two you got 1,77,000. Okay, now this 1,77,000 you got for year two. Okay, and 1,80,000 you are getting for year one. Okay, and 1,80,000 you are getting for year one. 1,77,000 you got for year two. So how will I bring the data of 1,77,000 what you got for year two on year one? So how will I do? So by discounting it at 14%. Okay. So what I'll do, so this is the second case I did. Now I'll do for the first case. So the cash inflow, so the cash inflow, so the cash inflow after first year, so the cash inflow after first year for the first case, whatever I can write, A case, B case, I can write, give them a name A, B, something like that. The cash inflow after first year for the first case would be 1,77,000. What you got, this you got after year two. So I want to bring it on year one. Year one cash inflow is 1,80,000. Let's do this calculation. So if I do this calculation, then 1,77,000. Everyone do with you also with calculator. Divide by 1.14. You get 1,55,000. 1,55,000. 263. 1,55,000. You got 1,55,263. 15789 plus 1,83,000. 1,80,000. So if I do this calculation, how much you will get? What is the value you got on this? You add 1,80,000. 1, 2, 3, 4. So you got 1,80,000. So this would be 3,35,263. This would be 3,35,263. 3,35,263.15789, something like that. So this is 3,35,263.157. So this is the cash inflow what you got after case one. So after case one, after first year. Clear, no? Everyone, you understand? So whatever the cash inflow I got after year two, that I discounted with 14% because 14% is the discounting rate of return. On that, I add the cash inflow after first year. So then I got 3,35,263.157. I believe everyone is clear with this. Okay, so now what I'll do now, this problem what I had, I can make it simple. How I'll make it simple? Now the same thing I can write it like this. Now the same problem I can write like this. So your initial investment was 2 lakh rupees. Your initial investment was 2 lakh rupees. Now year one. So year one for first case you're getting is how much you're getting for year one for first 3,35,263. 3,35,263. Point also, if you want, you can write point is 157 something. Okay. So 157. And for the second case, your cash inflow, and for the second case, your cash inflow is how much is the second case cash inflow? This is the cash inflow for second case. 4,15,614. 4,15,000. 4,15,000. 4,15,000. 614. 614. 614.035. And both of them have a probability of 0.5. And both of them have a probability of 0.5. Now I made this question like this. 2-year thing, I made 1 year. Ranjit, understand Ranjit. This is this is here I am in second year. Ranjit, understand, here I am in second year. Now for second year I am reaching first year. I am not going to year two. Please understand, from second year if I have to determine the present value, then I'll take 1.4 to the power 1.14 to the power 2. But I'm not reaching here. I'm not reaching from here. I'm reaching from second year. I'm reaching here first year. I'm going back 1 year. So from second year I'm going back 1 year. So I reached the year one. So that's why I discounted it with 1.14 to the power 1. because my objective right now is not to reach from year 2 to year 0. So when I have to reach from year 2 to year 0, I'll divide it by 1.14 to the power 2. If I have to reach from year 3 to 0, I'll divide it by 1.14 to the power 3. If I have to reach from year 3 to year 1, then I'll divide it by 1.14 to the power 2. If I have to reach from year 8 to year 6, then I'll divide by 1.14 to the power 2. I hope you understood this. So now what I'm trying to do, whatever the cash inflow I got here, that I'm trying to put it here. Then from here, I'll reach here one by one. Whenever, if you remember in first sem also, I taught you decision tree in statistics. There also I taught you the same thing. So one by one, we'll go back. So from year two, I reach year one. Now from year one, I'll reach year 0. I hope you by this time would have understood. Okay, so now the same problem I have summarized like this way. Now the same problem, whatever the data I got for year 2, I discounted it with by 14%, and I added on the year 1 data, and for the year 1 the probability is 0.5 only. Okay, so anyone have any doubt till now? Ranjit has cleared his doubt. Anyone else want to ask anything? Anything anyone want to ask? Please write in the message box. Clear everyone? Any question anyone? Anyone? Any question? Okay, I believe you have understood. So now what we will do, we'll discount this for the present year. Now we'll discount this. So what is the NPV of the project? So the NPV of project B. So the NPV of project B is equal to so this is zero point 0.5 into 3,35,263.157 plus 0.5 into 4,15,615,614.035 minus 2 lakh rupees. This is the NPV of the project. 0.5 means half you have to do. So 1, so 2, 13, 13 means 6, then 17, 7, 14, 1, 6, then 3, then 1, 5, 7, then 8, 5 something plus. So how much you are getting this? So this is 2, 207, 207, 207, 8, 207, 807. Okay, point how much? 0.035 something. 0.035. So you can write 0.017, 0.0175. Okay. So this minus 2 lakh. So this is 15, no? 16, 1 carry, 8, 9, then 5, then 8, then 3, then 14, then 15, then 7, then 3. This, so you got this total sum, this minus 2 lakh. So if you do minus 2 lakh, you get 175,438.596. So this you got as an NPV. So this you got as the NPV of the project B. Clear? Anyone want to ask anything? Anyone? Any doubt, anyone? So you got the NPV of project B this much. So this is the NPV of project B. So this is the NPV of the project B. This is the NPV of the project B, and before that was the NPV of project A. Whichever gives you the more NPV, you consider that project. Okay, so which of the project would you recommend and why? So which of the project would you recommend? So if I talk about project A, your NPV was how much? Your project A, your NPV was 29,332. This was the NPV for project A, and for project B, your NPV is coming around. How much your NPV is coming around? Your NPV is coming around 1,75,438. Hmm. So you will accept the project B over project A. Anyone want to ask anything? Anyone want to ask anything? Please write your doubts in the chat option. Any sheet you want me to show you? Any sheet you want me to show you? Please ask me your doubts. Any part you have not understood? So I guess nobody is replying. So I guess you people have understood what all I have done. So fine. So I'll tell you one shortcut way. This okay, guys. Okay, guys. There's a mistake. Is there? 1 minute, guys. Everyone, there's a mistake in this. 1 minute. I forgot to discount this. I'm very sorry. So this you have to discount. This is after year one. No? 1 minute. Let me do this again. There's a small mistake. Is there? So let me erase this part. Hmm. 1 minute. Hmm. So I have to discount it. 1 minute. Hmm. Hmm. So your your outflow was 2 lakh rupees. Your outflow was 1 minute. Your outflow was 2 lakh rupees. Your outflow was 2 lakh rupees. And now if you do the if 2 year data, if you bring on the first year, so your inflows is either how much is your either that is 3,35,263. It is either 3,35,263 3,35,263.157 with probability 0.5 after year one, or it can be either it can be It is either it can be 4,15,614, 4,15,614, 4,15,614 point 035, point 035 with probability point 0.5. So you need to understand this is happening after, you need to understand that this is happening after year one. You need to understand this is happening after year one and this is happening after year zero. Okay. So what I will do, I'll find the 50% of this. Point 0.5 is the probability. So I'll find this value. So this is 116 or 117, and then 6, then 3, then 1, then 5, then 7, and then 8, then 5. You can check this zero point 0.5 of this. It should be this. So you can check with zero point 0.5 of this. This should be this. So this would be zero point 0.5 into 335 263.157, that is 167,631.5785. Okay, so you got this value. Now similarly 0 0.5 is a probability for this. So this is 2, then 0 7, then 8, then 0 7.01, then 75. Okay, so 0 0.5 of the other one. So that 415,614, then 0.035 into zero point 0.5 is 207,807.01745. So this is the year one data what you got. So if you do the sum of this, so this is the cash inflow what you're getting after year one. So if you do the sum of this, 167, then 631.5785. So you got 375. You got 375,438.596. You got this total cash inflow after year one. You got this total cash inflow after year one. This is the total cash inflow what you get after year one. So the probability of getting this is zero point 0.5. The probability of getting this is 0.5. So the net cash inflow what you're getting is 3,75,438.596 after year one. This is after year one and this is after year zero. So what is the NPV? So the NPV of project B, that would be 3,75,438 point, how much is the point? 0.596 divide by 1.14. We will bring it up for year 0 minus 2 lakh. Minus 2 lakh. So now the year 1 data, like Ranjit wanted to ask. So now the year 1 data I bought for year 0. So this when I divide by 1.14. So this when I divide with 1.14. So this when I divide 3,75,438.596, when I divide it with 1.14, I got 3,29,332. This I subtract with 2 lakh. This I'll subtract with 2 lakh. I'll get 1,29,000. I'll get 1,29,000. 332, 332.10175. This is the NPV of project B. Okay, so this is the way how we should do. Anyone want to ask anything? Anyone, any doubt? Anyone, any doubt? Please write in the chat option. Okay, so no one is replying anything, so I'm assuming that you are understanding. Now the next thing, the same calculation I'll show you by other way. Now the same calculation, whatever the calculation I did, so I'll show you the other way of doing the same calculation. Okay, so whatever the calculation I did, I'll show you the other way. Now this way, what we did step by step. So whatever we did step by step. Now the same thing we can do it one step. So how we can do for the one step, I'll show you that. So I'll do this NPV of project B one more time, and this time I'll do it one shot. So there would be too much calculation will be done, but that way it will help you to understand. So determination of same thing I'll do by other way. So now determination of NPV of project B, determination of NPV of project B, determination of NPV of project B. Now the same thing I'll do in other way. You can see determination of NPV of project B. I'll focus on project B. Project A already you know. So project B start from where there's a yellow color. So it is estimated that the cash flow associated with project B would require 1,80,000 and 2,20,000. Okay, next year. So the initial investment. Let me write little bit small. So 2 lakh is your initial investment. Then it can be 1,80,000. It can be 1,80,000 with probability 0.5, or it can be 2,20,000 with probability 0.5. So it can be 1,80,000 with probability 0.5. It can be either 1,80,000 with probability 0.5, or it can be 2,20,000 probability 0.5. If 1,80,000 receive in the first year, if 1,80,000 receive in the first year, the cash flow for second year is 1,50,000, 1,80,000. So if 1,80,000 receive in first year, so cash flow for second year can be 1,50,000. It can be 1,50,000. It can be 1,50,000. So if 1,80,000 receiving first year, it can be 1,50,000, 1,80,000, 2 lakh, 1,50,000, 1,80,000. It can be 1,50,000. It can be 1,80,000, or it can be 2 lakh. So it can be 1,50,000. It can be 1 lakh, 1,50,000, 1,80,000, or 2 lakh. And what probability for them is 1,50,000, 0.3, zero point 0.4, and 0.3, 0.3, 0.4, 0.3. So 0.3, 0.4, 0.3. Okay. So these are their probability: 0.3, 0.4, 0.3. Okay, fine. Okay, so if 1,80,000 is received in the first year, then the cash flow for second year would be 1,50,000, 1,80,000, and 2 lakh. Okay, and their probabilities are given to you. Okay, in case the first year the cash inflow is 2,20,000, the second year likely cash inflow would be 1,80,000. It would be 1,80,000. It can be 1,80,000. It can be 1,80,000. Or it can be 1,80,000. It can be 1,80,000, 2,70,000, 1,80,000, or it can be 2,70,000. It can be 1,80,000, or it can be 2,70,000, or 2,20,000, or it can be 2,20,000, or it can be 2,20,000, or it can be 2,20,000. So it can be 1,80,000, 2,70,000, or 2,20,000. So each 0.3 point each with point. First two is 0.3. This is 0.3, 0.3, and this is 0.4. Okay. 0.3, 0.3, 0.4. Okay, fine. So guys, so this for project B, this is the way. Anyone have doubt with this? So whatever the flow is there for project B, this I can draw this flow for the project B like this. Again, I'm telling you, you have to understand that this is for year zero. This is year zero. This is year zero. This is year one. This is year one. This is year one, and this is year two. So you have to understand. Okay, so where your discounting rate is 14%. Okay, now I'll do this problem at one shot. So one equation, I'll solve this problem. Everyone, please draw this in your notebook. Otherwise, you will not understand. Everyone, please draw this in your notebook. Based on the information what I get from the case study, uh, everyone draw this in your notebook. Then we'll start. I'm giving you 2-3 minutes time to draw this in your notebook. Anyone doubt? Is this clear, everyone? So I believe you have drawn this on your notebook. Let me start solving this at one step. So one step I'll solve this in one equation. I'll solve this. Now see this one equation. How will we solve this in one equation? So I'll write this as minus 2 lakh plus 1 lakh 80,000 1 lakh 80,000 into zero point 0.5 plus 2 lakh 20,000 into zero point 0.5. Okay, divide by 1.14. Okay, this is after 1 year. I am bringing it on year 0. Okay, then plus. Okay, so this is year 0. I hope everyone is understanding. Everyone is with me. So this is year 0 plus this year 1. This year 1. So this year 1 data I'm putting on year 0. So the discounting rate is 14%. So divide by 1.14. Now I'm going to year 2. You have to understand, when I'm entering into the year 2, these values, when I'm entering into the year 2, these values what you got, when I'm entering into the year 2, you need to understand that these values what I got, these values what I got, these values what I got, this values totally depend on this probability. I hope you understanding. This will give this probability. Are you understanding? So it's like this, that if Amit will get married tomorrow, then the children of Amit will marry someone else, like that. So the whatever the grandchildren of Amit gonna do, that depends on what Amit gonna do. I hope you are understanding. So the outcome what you're getting here, that depends on this probability. I hope you are understanding. So that's why what I will do now, after this what I'll do, I'll write point five for this probability into zero point 0.3 into 1,50,000, 0.5 into zero point 0.3 into 1,50,000 plus zero point 0.4 into 1,80,000, 1,80,000 plus zero point 0.3 into 2 lakh 0.3 into 2 lakh. So this done. So this, so zero point 0.5, I'm talking about this case done. So zero point 0.5, this is a probability for that. So for 0.5 into 0.3 into 1,50,000 plus 0.4 into 1,80,000 plus zero point 0.3 into 2 lakh. So this is 0.5 for that, plus on this, plus zero point 0.5, again 0.5, again 0.5 for what, again 0.5 for this. Now I'm entering into this. So again 0.5 plus, again 0.5 plus, again 0.5 plus zero point 0.3 into 1,80,000, 0.3 into 1,80,000 plus 0.3 into 1,80,000 plus zero point 0.3 into 2,70,000 plus zero point 0.3 into 2,70,000 plus zero point 0.4 into plus zero point 0.4 into 2,20,000 plus zero point 0.4 into 2,20,000. Okay, this whole divide by, this is for year 2, whole divide by 1.14 to the power 2. Okay, so Ranjit was asking why you are not doing divide by, this is year 2, why you are not dividing by 2. So I hope you are understood now. So now I'm doing it together. So in the first case, what I was doing, I was bringing the year 2 data on year 1 data, and then from year 1 data to year 0 data. So we are doing step by step. Now this way I'm not doing step by step, I'm doing directly. So this is the find one equation. In one equation you can solve this. I hope everyone is with me. You are enjoying this, and we have intensified our calculation, and I believe you all are loving doing this calculation. So this is NPV. So this is minus 2 lakh, minus 2 lakh plus 50% of 1,80,000 is 90,000. No, 1,80,000, 50% 90,000 plus 50% of 2,20,000 is 1,10,000 divide by 1.14 plus okay, plus, now let me do this calculation, plus zero point 0.5 into, let me do this calculation, inside calculation. This is what is 30% of what, zero point 0.3 into 1,50,000 is 45,000 plus zero point 0.4 is 72,000, then plus zero point 0.3 is 60,000. Okay, plus then again zero point 0.5 into, now zero point 0.3 of 1,80,000 is 54,000 plus zero point 0.3 into 27,000, 2,70,000 is 81,000 plus zero point 0.4 is 88,000. Then this whole divide by 1.14 square. This whole divide by 1.14 square. I hope you are understanding and you are enjoying doing this calculation. I believe you love maths, so definitely you would be enjoying this. So the NPV for the project B, if I say what is the NPV of project B, so the NPV of project B is minus 2 lakh, minus 2 lakh plus, acha, 1 lakh 10,000 plus 90,000 would be 2 lakh. So this would be 2 lakh, 2 lakh, 2 lakh divided by 1.14, 2 lakh divided by 1.14. So 2 lakh divided by 1.14. So this plus this plus zero point 0.5 into, how much is the sum? 45 plus 72. 45 plus 72 plus 60. 45 plus 60 is 105. 105, 105 plus 72. 105, 100 plus 72 is 172. 172 plus 5 is 177. So 117, 177, 172 plus 5, 177, then 30 plus, okay, 17730. So this is, okay, this plus 0.5 into This is if I do the calculation 30, then 8 plus 4 12, 12 plus 1 13, 13 1 carry, then 8 plus 8 16, 16 plus 1 17, 17 plus 5 17 plus 5 22. So again I'll do 12 13 1 carry, then 16 plus 6 22. Okay, this divide by 1.14 square, divide by 1.14 square. So the NPV, so the NPV of project B, NPV of project B, NPV of project B is equal to minus 2 lakh, minus 2 lakh plus 2 lakh divided by 1.14, 2 lakh divided by 1.14. So 2 lakh, 1, 2, 3, 4, 5. 2 lakh divided by 1.14 is 1 lakh 75,000, is 1 lakh 75,000 438.59, 0.5964, 0.5964, then plus, so plus this is how much? Half of this would be 8, 16, then 8, 8 at 5, no? So 8, 16, 117, then again 8, 1, 8 at 500, 88,500, then 88,500 plus this is 1115, then 00, divide by 1.14 square. Okay. Any calculation mistake, just kindly let me know. If you find any calculation mistake, if you find any calculation mistake, just let me know. Okay. So 111,500 divided by 2, 55, 223 into 4, 223. Okay, so I got this now. So 111,111,500 plus 88,500. This divide by this, divide by 1 point, divide by 1.14, again divide by 1.14. So you got 1,53,893. So this is 1,53,893.5056 plus this is 1,75,438.5964 minus 2 lakh, minus 2 lakh. So you need to do this calculation. This is the NPV of project B. This is the NPV of project B. That is equal to this, this plus 175,438.5964 minus 2 lakh, 1 2 3 4 5 is 1 lakh 29,332, 1,29,332.1020. This is a direct answer I got. Let me compare with the previous answer, 1,29,332. You can see this. So when I did step by step, I got this answer, 1,29,332.1015. This I did step by step. This I did step by step. When I did step by step, I got like this. And directly also I can do this by this equation. You can see the equation. So directly I frame this equation. And then also when I did, I got the same answer. I got the same answer. So my answer is, so I got the same answer, this answer, same answer. Here, anyone have any doubt to ask? Anything you want to ask? Anyone? 1,29,332. Anyone want to ask anything? Whatever way I'll do, I'll get the same answer. To learn both the way, because case study, the decision tree in case study definitely will come. So the the decision tree in case study will definitely will come, and you need to know how to solve this. So out of project A and project B, if I see project A, if I see the project A, the NPV of project A, if I see project A, the NPV of project A is around 29,332, while if I see the NPV of project B, so the NPV of project B, I'm getting around 1,29,332. So definitely I'll prefer project B over project A. Anyone want this sheet? Do you want this sheet? What I'm doing? If you want this sheet, then I'll save this sheet for you and I'll forward in the group. If you want this sheet, if you don't want that sheet, then fine. If you have anything to see in the future, then I'll save this sheet for you people and I'll forward in the group. So let me know whatever you say, I'll do that. Okay, fine. So anyone want to ask anything? Any question? Anyone? Anyone? Any question? Any question? Anyone? Bharat, Amit, Darshan, Jayant, Madan, Malika Arjun, Manju, Monisha, Nandita, Ranjit, Roja. Any question you want to ask? Suhas, Shiv Prasad. So this came for your which exam this came? Uh, so I'll save this and I'll forward you people. So exam time, you can refer this so that in case of any confusion, this sheet will be there with you. So you will not have any confusion. Calculation part you want to see, you can see it anytime. So this sheet I'll save for you people. And okay, so this much for the today class. Fine. So let me save this. I'll write what I'll write case study finance. Today date is 27th 27th August. Okay, so I have saved this. So anyone want to ask anything? I don't know where it went. Anyone want to ask anything? Believe it. I see that. Anyone have any doubt to ask? Anything you want to ask? So because there's no point of starting anything new now. So we have discussed this case study, which came in which year it came. This came in year. We have discussed this case study, which came in this year, July 2016. So we have done this case study. I believe there was some problem with the questions. One question, Ranjit, I guess you have sent me, no, Shiv Prasad has sent me the complete question for that. I'll see that. Okay, so uh, whatever doubts you have, just keep let me know so that we will understand and how best way we can help each other so that you get what you're expecting from. Fine. So guys, any question, anyone before I end the class? Anyone knows what is derivative? Anyone knows the difference between forward and future? Anyone? What is the difference between forward contract and future contract? Anyone? Anyone want to write? Tell me the answer. What is the difference between forward contract and future contract? What is derivatives? So forward contract is a OTC based instrument, while future contract is a standardized agreement which trades over the exchange. In the case of in the case of forward contract, the terms of the contract is mutually decided between the long and short position holder, while in the case of future contract, the terms of the contract is decided by the exchange, and both long and short has to follow the terms of the contract. Fine. So a lot of differences are there regarding future, forward, options. While in the case of futures and forward, your payoff matrix is a linear, but in the case of options, your payoff matrix is a non-linear payoff matrix. In the case of futures and forward, you have the obligation to follow in the future, but in the case of options, you don't have any obligation to follow in the future. So all that we'll discuss about future forward options gradually in the future classes. So we need to wait for that part. So I hope you are enjoying the classes. Your feedbacks are most likely acceptable. Whatever you want to ask, you can ask any questions. So please, other colleges also, if you have any friends who are doing MBA in fourth semester and they have this subject called risk management and derivatives, you can forward my videos to them. Tell them to subscribe to my channel so that more and more people I can reach, and that gives me a lot of motivation to keep doing the hard work in the same way. So I really appreciate your hard work and the time what you have put for me. With that intention, I like to say goodbye to everyone. So before that, I just want to know if anyone want to ask any question, please ask me. If you are, if no one is replying, so I'm assuming that you have understood what all I have covered. Then I'll wind up the class. So guys, I believe this is the end of the class. It was really nice teaching you all. So thank you everyone.